Good morning. All right, so today we're going to continue looking at, make sure I get this right on the screen, system of equations. The last thing that we did was the substitution process. So I just wanted to say hi. Hope you guys are doing well. Yeah, I know I got some growth down here, but no shave November is what I've heard, but we'll see. But anyways, I don't know what next week's going to bring. Nobody knows. I've asked, but they're probably going to meet again on Thursday and make a decision. So we'll go from there. All right, so back to this screen, and it says system of equations. All right, so the one that we're going to do today is called the elimination method. So again, remember I said we could graph, which I showed you last week. That's one way to do it, the graph. And then another way would be the substitution. And, that's another one that we did last week. But the third and the one that we're going to talk about today, most of the time today, it's called the elimination method. We're going to do two examples. And I want you to write both examples down in your notes. Okay, so we got elimination method. All right, so here's example number one. I'm just going to make it up out of my head, which isn't always good because sometimes you don't get an even answer. But let's say we have 3x minus 2y equals 5, and then we'll say 4x plus 2y equals 9. Okay. So go ahead and write that down. If I get going too fast, remember you can always just hit pause and write everything down. So the elimination method, you basically follow the name. We're going to eliminate one variable and solve for the other one. And solve for the remaining variable. All right, and then it's just kind of like using like terms. And notice how I've written the system. It's with two equations with two variables, two unknowns. Two equations, two unknowns, x and y, x and y. Okay, and so we've written them in a vertical fashion here, so they're not across from each other or anything like that. Now, just like the old school, if I were going to take 8 plus 5 and get 13, and I write it like that, do the exact same thing, except I know it's a little bit more complex because we got variables involved. All right, so now the idea is when we use the elimination method, we want to add or subtract the equations to eliminate a variable. But in order to do that, this is so important, they have to have the same coefficient. All right, now coefficient, if you don't remember from your algebra last year, coefficient is the number that's in front of the variable. So 3 is a coefficient, 2 is a coefficient, 2 is a coefficient, 4 is a coefficient. These numbers are not called coefficients because there's not a variable behind them. They're called constants. C-O-N-S-T-A-N-T, constant. Okay, so we've got coefficients and we've got constants, and these are all part of the equations. And we need to eliminate a variable. Well, the only way to eliminate a variable, think of it like this. If I have 5x minus 5x, that gives me 0x. What's anything times 0? That's 0, so it eliminates. And so basically to eliminate a variable, I need the same coefficient with opposite signs. The same coefficient with opposite signs. All right, so if I give a quick look at this, it's pretty obvious, I think, that the same coefficient with opposite signs are right here. -2 and +2. And so then we don't just add those two together, and we add in this case, so it's called addition for the elimination method. We're using the addition, okay? And we don't just add these two, we have to add the entire equations. Okay, so we're going to take this entire thing and add it to this. Now that's why we have it lined up like this with like terms. So 3x plus 4x gives me 7x. Negative 2 plus positive 2, that's the whole purpose for doing this method. That cancels out. And then we have 5 plus 9, and we have 14. And so I'm going to rewrite that. We have 7x equals 14. And lo and behold, the y variable is gone. Because that's eliminated. It's gone. And so now we solve for the other variable. Divide by 7, and we end up with x equals 2. Are we done? No. Remember, the solution of a system of equations, the solution is a point of intersection. Unless the two lines are parallel or they're the same line, the solution is a point. And so we are looking for an x and a y. X and a y. So now we've already found the x. What do you think we must do for the y? That's right. You want to put it back into either one of these original equations. Let's put it into the first one. So we have 3 times 2 minus 2y equals 5. Now we're going to solve for y. Because that's our variable we still don't know. We get 6 minus 2y equals 5. Now I'm going to subtract 6 from both sides. I have negative 2y is equal to negative 1. 5 minus 6. And then I'm going to divide by negative 2, and it looks like I have y is equal to positive 1/2. And so my solution to the system of equations is 2 and positive 1/2. Okay, let's do one more. This one a little bit more involved. Let's go, all right, example, we'll say 3x minus 7y equals 2. And then here we'll go 6x minus 3y equals we'll say 11. All right, so I don't know, I'm doing it in my head, so I'm trying to figure it out a little bit in my head as we do this. So 3x minus 7y equals 2, 6x minus 3y equals 11. All right, we're going to use the elimination method. All right, so now, just like as we did before, we want to see if there's any variables that have the same coefficients. So I'm going to put a question mark. I don't see that. 3 and 6, 7 and 3. Because over here when we did it, we had 2 and 2. So that made it easier. Okay, and so we don't have that on this one. And so what we have to do is we have to manipulate the equations. We could divide this by 2 and get this to be 3. Or we could multiply this by 2. I think multiplication is easier. So we're going to, watch this bracket, I'm going to multiply this entire thing by 2. And that we can do that at any time. That keeps the equation equal. And so when I do that, I got to distribute it into everything. All right, let me rewrite. So it'd be 6x minus 14y equals 4. And then this is 6x minus 3y equals 11. Okay, so that's our new system. Okay, so now we have the same coefficients. But now in this case, since they have the same sign, we're going to subtract. All right, so whatever I do to one term, I have to do to both terms, all the terms. So 6 minus 6 would give me 0x, and we need to write it. Now careful here, negative 14 minus a negative 3. That's actually plus 3. So it would be negative 11y. And then 4 minus 11 would get us negative 7. Divide by negative 11. We have y is equal to positive 7/11. Yeah, yuck, a fraction. But it'll work, okay? Okay, so now let's put it into, it doesn't matter which one. Let's just put it into the original first equation like we did before. Okay, so we have 3x minus 7 times 7/11 equals 2. So 3x, now we're going to solve for x, that's our idea, minus 49/11 equals 2. 7 times 7. Then I'm going to add 49/11, so I have 3x is equal to 2 plus 49/11. If you've got a calculator, it can help you out here. You need a common denominator. 3x is equal to 22/11 plus 49/11. Yuck, yuck, yuck. 71/11. All right, now we divide by 3. When we divide by 3, it's the same thing as taking the denominator times 3. And so I end up with x is equal to 71/33. So my two ordered pair from my point of intersection is 71/33 and 7/11. There's our solution. All right, so that's elimination method. We're going to do some more tomorrow, but this is good. Make sure you get these notes down and you get them submitted so I know that you guys are staying engaged. Remember, we have a quiz on Friday. All right, have a great Tuesday.